Hi all, today we are going to discuss about the application of Cauchy-Riemann equations. The first application is the harmonic function. Harmonic function. We know that we have a function in Z domain. That means it is represented as u is a function of x and y plus I is the imaginary term. It is also a function of x and y. We have to find the harmonic function. Okay, for that, consider we have the CR equation dou u by dou x is equal to dou u, this is u, dou u by dou y, and dou u by dou y is equal to minus dou v by dou x, this is v, this is v. Okay, now differentiating the above equation with respect to x, so we get dou square u by dou x square, which is equal to dou v by dou x of dou y, dou v by dou x of dou y, and here dou square u by with respect to y and y, dou square u by dou y square is equal to dou by dou y of dou v by dou x, this is minus. Then adding the above equations, we get dou square u by dou x square plus dou square u by dou y square is equal to dou v by dou x dou y minus dou v by dou x dou y, which is equal to 0. That means we can write the above equation as del square u is equal to 0. Del square u is equal to 0. If del square u is equal to 0, we can say that it is a harmonic function. It is a harmonic function. Similarly, we can calculate dou square v is equal to 0. So, from here, we can conclude that if f of z is analytic, then del square u is equal to 0 and del square v is equal to 0. So from Cauchy-Riemann equations, we can check a function is harmonic or not. We can check the harmonicity of a function, which is useful in electromagnetic radiations, etc. Okay, so the condition for harmonicity is del square u is equal to 0 and del square v is equal to 0. Next, our next application is, the second application is, if real part is given, then find imaginary part. Okay, we know that real part is u of xy. We have given a function that is a real part. Then we have to find v of xy. Okay, for that, consider, we know the CR equations dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. Okay, now integrating, we have the equation v of xy. We have to find the imaginary part. For that, we have to differentiate it. dv is equal to, is a function of x and y, so we can write dou v by dou x into dx plus dou v by dou y into dy. Then integrating, dv is equal to integrate dou v by dou x dx plus integral dou v by dou y dy. Then we have to write the equation dou u by dou y. We know that dou v by dou x is dou u by dou y plus integral dou u by dou x dy. Dou u by dou x into dy. That is, this is the equation. This is the v. So it's a, for here here we are taking y as a constant. In this term, we can select y as a constant, and here no x terms are considered. We are not considering x terms in the second term. Okay, for example, so this is the formula for finding imaginary part from real part. Okay, so for example, consider we have the equation u is equal to x cube minus 3x square y. Then find v of xy. We have the equation v is equal to integral dou u by dou y dx. Here it is dx plus integral dou u by dou x dy. So from this equation, dou u by dou y is minus dou u by minus 3x square dx plus integral dou u by dou x is 3x square minus 3y into 2x dy. Okay, here we are having x terms. So we are not considering this term. Then we have to find here this 3x square dx, which is equal to integrating this x cube by 3 plus 3. That is x cube plus c is the imaginary part. So f of z is equal to ux of y plus I v xy, which is equal to x cube minus 3x square y plus I x cube. Okay. Similarly, we can find the imaginary part. Then the third application is imaginary part is given. Find real part. Same as the above equation, we have u is equal to integral dou v by dou y into dx minus dou v by dou x into dy. Then here also we are considering only here y is a constant. Then no x terms. We are not considering the no x terms. Not considering the x terms. Okay. For example, p is equal to x square minus y square minus y. So u is equal to integral dou v by dou y. Dou v by dou y is equal to minus 2y minus 1 into dx plus integral, that it is not plus, it is minus integral dou v by dou x 2x dx, which is equal to integral, here y is a constant, then we can say that minus 2xy minus x minus 2xy minus x. Here we are not considering because it is containing x terms. Then the dx. Okay. So the answer is minus of 2xy minus x plus c is the real part. Okay. So we have discussed the three application of CR equation. Next we have to construct. Next we are going to discuss about the construction of analytical function. We know that f of z is equal to u plus iv. Okay, this is the form of a complex function. So we have to find the analytical function. So we have to apply CR equation to prove it is analytical function. So for that, consider f dash of z, or differentiating with respect to x. Differentiating f of z with respect to x. That is f dash of z is equal to dou u by dou x plus I dou v by dou x. We know that from CR equation, dou u by dou x is equal to dou u by dou y, and dou u by dou y is equal to minus dou v by dou x. Okay, so we are converting v in terms of y. So we can say that dou u by dou x minus of I dou u by dou y. Okay, this is f dash of z. Then after finding the partial differential equation, we put x is equal to z and y is equal to 0. Then we have to integrate it. Then we have to integrate f dash of z dz. Okay, then we get the function in f of z. Okay, this is the procedure. First we have an example. For example, we have the given u is equal to x cube minus 3x y square. So we have to find or construct f of z. So first of all, we have f of z is equal to u plus iv. Then f dash of z is equal to dou u by dou x minus I dou u by dou y. Okay, then which is equal to dou u by dou x is equal to 3x square minus 3y square plus I minus I dou u by dou y, that is minus 6xy. Okay, then we get 3x square minus 3y square plus I into 6y. Then put x is equal to z and y is equal to 0. Then we have this is equal to 0, this is equal to 0. Then we get 3z square. Then f of z is equal to integral f dash of z, which is equal to dz, which is equal to integral 3z square dz, that is equal to z cube plus c. Then we get our function f of z is equal to z cube plus 3. Okay, this is how we construct imaginary construct. Likewise, if we given, for example, we given v is equal to y square minus x square, construct f of z. That for that we have the equation f of z is equal to u plus iv, differentiating with respect to y, differentiating with respect to x, dou u by dou x plus I dou v by dou x. Then we have to consider CR equation, dou u by dou x is equal to dou u by dou v by dou y. So we can write it as dou v by dou y plus I dou v by dou x. So f of z is equal to f dash of z is equal to dou v by dou y, that is 2y plus I minus 2x. Then we put x is equal to z, y is equal to 0. This term goes to 0. Then we get minus I to z. Then f of z is equal to integral minus I to z dz, that is equal to minus I to z square by 2 plus c, which is equal to minus I z square plus c. This is the equation.